Okay, so part two of work. This is where things get a little bit complicated. The reason things get complicated is we're starting to talk about a lot of stuff in two dimensions. And anytime you talk about stuff in two dimensions, you're talking about trigonometry. Now, just to make sure we're on the same page, the long leg is going to be h for hypotenuse. And the angle here, we're going to use theta. Now, if you are a fan of the SOHCAHTOA method, the leg over here opposite theta is going to be your opposite leg, and the leg over here right next to theta is going to be your adjacent leg. Now, if you're someone that doesn't really like trig, there's some key words that you can look for in the problem. Now, if the key word says from the horizontal, if it says from the horizontal, your triangle looks like this. Okay? And your x component of the vector is going to be h cosine theta. And the y component of your vector is going to be h sine theta. But if the problem says from the vertical, your triangle is going to look something like this. Now, in this case, the x component of your vector is going to be h sine theta. And the y component of your vector is going to be h cosine theta. Now, if we look at these, they look very similar, but they're kind of opposites. So from the horizontal, x is cosine, but from the vertical, x is sine. On the horizontal, y is sine, and from the vertical, y is cosine. Now, what that means is that you can use these two sets of equations over here only if it's from the horizontal. And you can use these two sets of equations over here only if it's from the vertical. So you have to pay attention to which angle they're giving you. Now, what does that mean? Well, if we remember back from our last video, positive work means force and displacement are in the same direction. Now, what that means is, so we have this bicycle right here, right? There is an applied force to push the bicycle up the road, and your displacement is also up the road. Now, what that means is your applied force and your displacement are the same direction, which means you don't have to do anything at all. Okay? So applied force and our displacement, same direction, means no trig. On the other hand, if we're looking at the work done by gravity in this case, wrong one. Let's erase that. There we go. Our force of gravity is pulling down. Okay, which means these are in kind of two different planes. So that means our force of gravity is pulling down, and our displacement in the y is going to be up, but our displacement in the x is going to be to the left. Now, because of this, we don't care about the displacement on the plane different from the force. So, to flip that over to make it make a little bit more sense, we only care about the displacement in the direction of the force. Yeah. We only care about the displacement in the direction of the force, which means we only care about the vertical displacement anytime we're talking about the force of gravity. When you're having applied forces, displacements, those two are in the same direction, so we don't have to do anything. But down here, we would have to break down our displacement into x and y and only care about the vertical displacement anytime we talk about gravity. So let's look at this roller coaster right here. Okay, so we know that the force of gravity is going to be down. And our displacement here, we have our displacement in the y and our displacement in the x. So our displacement in the y is going to be down. Our displacement in the x is going to be to the right. Now, if you remember, we only care about the displacement in the direction of the force, which means we can cross out our displacement in the x. We do not care about the displacement in the x anytime we're talking about gravity. So what we do in this case is we have our displacement in the y, because if we look at this, this matches our triangle from when we talked about an angle from the horizontal. So that means our displacement in the y is going to be h sine theta. So our displacement in the y, our hypotenuse is 30 meters. And then we have sine, and our theta is 60 degrees. So we go ahead and pull up our calculator here. First thing we're going to do is make sure our mode is in degrees. And that means we type everything in. 30 sine 60 equals about 26. So our displacement in the y is going to be about 26 meters. And I know because it's going down that this is going to be negative. Okay, and so we would then use this and plug it into our formula for work. So the next slide, let's look at a full problem. So physicists, for whatever reason, really like problems that talk about the work done by gravity. So in this case, let's describe our situation. We have our evil corporation. Our evil corporation has captured a 1,000-kilogram car, presumably occupied by the good guys, and is pulling it along at an angle of 60 degrees above the horizontal, and it ends up with a displacement of about 20 meters. So what is the work done by gravity? So in this case, we care about the force of gravity, which means our force of gravity is going to be mg, which is going to equal 1,000 times negative 9.8, which gives us negative 9,800 newtons. And now, if we remember from what we were talking about earlier, our force of gravity is pulling down. However, our displacement has an x and a y component. Our displacement in the y is up, and our displacement in the x is to the left. So the force of gravity is vertical, so we care about the vertical displacement. So we're going to go ahead and cross out our displacement in the x. So what we care about is our displacement in the y, which is going to be h. This is, again, a from the horizontal problem. So our displacement in the y will be h sine theta, or 20 sine 60. So let's plug that into our calculator. 20 sine 60. Okay, that gives us a displacement in the y of about 17.3 meters. And we know that's in the positive direction. So our calculation for our work is going to be force times displacement, which means our work is going to be negative 9,800 times 17.3, which we'll go ahead and plug that in. Negative 9,800 times 17.3 gives us a work of negative 169,540 joules. And that is the work done by gravity in this sort of problem. So there's a lot of steps, but when you break it down, each piece isn't too bad. So that goes ahead and ends part 2 of work.